Okay, so we're going to do an example problem that talks about that asks us to determine what is the stress distribution in a cylinder. So we're going to want to figure out what is the radial stress and what is the tangential stress for a cylinder that has an inner diameter of 2 inches and it has an outer diameter of 6 inches. Okay, it has an internal pressure of 5 ksi. All right, and it has an external pressure of 0 ksi. Okay, um, so um, so for these types of problems, because uh, there's no rotational velocity, they really are quite simple. You just have to take the variables that you were given in the problem and you just have to plug them into the equations for sigma r and sigma theta. Okay, so if we do that, we plug in all of our values here for sigma r, we'll end up getting 5,000 pounds per inches squared times their internal radius, which would just be 1 inch squared, minus our external pressure, which is 0, times our outer radius squared, plus the ratio of our inner and outer radius, which would be 1 inch times our outer radius would be 3 inches. All right, and then um, our radius here. All right, then we can square both of these terms here, and then we take the difference between our internal and our external pressure. So our external pressure is 0, our internal pressure is 5,000 pounds per inches squared. All right, and then we divide by the difference in our radius and our uh, our radius and our external radius and our outer radius and our inner radius. Our outer radius is 3 inches squared, and our inner radius is 1 inch squared. Okay. Um, so, all right, we can then repeat this process for sigma theta. What you'll notice about sigma theta is that, or I should say, so if we evaluate all of this for sigma r, what we end up getting is sigma r is going to be equal to 625 pounds per inch squared minus 556.25 pounds divided by the radius squared. Okay. Um, all right. Now, if you look at sigma r and sigma theta, you notice that these equations are exactly the same. So they have the same terms in them, except for the only difference between the two is this positive sign and this negative sign. Okay. So, so the only thing that we have to take into account for here is that difference in sign. So we're just going to change the one term in this equation. So sigma theta would be equal to 625 psi plus 5625 pounds divided by the radius squared. Okay. So these two functions are functions of r, and if we plotted them from over a range of r values from the internal radius to the external radius, which would be in this case, it would be the internal radius starts at 1 inch, and the external radius would be 3 inches. Okay, we could plot those. So from our inner radius to our outer radius, we could plot both sigma theta and sigma r. Okay, so notice that sigma r, if you do your equation right, should be equal to the internal pressure. So it's about 5 KSI on the inside. And then on the outside, this is our external pressure of 0. Okay? Alright, so hopefully if you do your equations right, the boundary conditions should agree at the inner and the radial stress of the inside should be equal to the inner diameter, and then the external stress should be equal to the pressure, the external pressure. Okay. All right. So that concludes this example problem on how to determine the stress, the radial and the tangential stresses within a pressurized cylinder.